Welcome back to Graspable AI, videos for teachers who want to know more about AI and how it affects the world, education, and our students. This video is about the pace of the AI progress, one of the most and probably the most important question when it comes to understanding what AI means. And zooming out a bit, we have at least 4 different ways that AI affects education, and now this video focuses on system level effects on education. So this is understanding what it does, what AI means on a really big level. Most of this video, basically all of it, will be trying to catch up to what AI can do today. But I'm going to rewind a bit first, starting in 2019. Then a large language model called GPT-2 was released, and there are still some places on the internet where you can try to use it. There were no chatbots available, no back and forth typing in or writing in a simple chat interface. Instead, you wrote sentences or gave the large language model some text, and it was supposed to complete it or continue the text from there. And right now, I'm trying to get it to count to 10. So I'm giving it a pretty clear start, prompting it to, or trying to get it to count to 10. And we'll see what happens here. Submitting the text, and it goes 1, 2, 3, 4, 5, 11, 12, 13, loses track of what it's doing. And again, I'm going to count to 10, 1, 2, 3, 4, 5 for the whole of it. Let's see here, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, well, yeah. So sometimes it gets it right, sometimes it doesn't. This was the state of the art in 2019 when it comes to language-based AI. In May 2024, we had, well, jumping forward quite a bit here, we have AI that doesn't only work with text and chatbot interfaces, but this one also can look at images and understands mathematics quite well. It doesn't show very well on this image, but here's a math problem, and this demonstration is from Khan Academy, kind of, and they have some kind of AI tutor helping this student.
I'd be happy to help. Let's look at the problem together. Can you first identify which sides of the triangle are the opposite, adjacent, and hypotenuse relative to angle alpha?
All right, so I'm pretty sure this is the angle alpha right here, right?
Perfect. That's correct. Now, looking at the triangle, which side do you think is the hypotenuse?
Remember
the hypotenuse?
I'm not totally sure. I think it might be this one, but I really am not sure. This side AC.
You're close. Actually, side AC is called the adjacent side to the angle alpha. The hypotenuse is the longest side of a right triangle and is directly opposite the right angle. Can you find which one is the hypotenuse?
All right, so we see here that AI has progressed quite a bit. It understands mathematics quite a bit. It's still kind of glitchy, and this is a demonstration, so you can assume that this product doesn't really work as well as it looks right here, but quite a leap from 2019. April 2024, a month before the previous video, we have humanoid robots, AI-powered humanoid robots. This one is from China. I think it was the first one commercially available, costing $100,000 or something like that. Just a brief view of this one. Yeah, and I usually don't talk very much about physical AI at Graspable AI, but robotics like this is another type of general purpose AI that I think is really important to keep track of. I would say that robotic AI is basically at the same stage as GPT-2 was in 2019. But robotics are advancing as well, and they're being tried out in manufacturing industry and things like that. September 2024, we went from having the old school large language model and introducing the reasoning language models that are built to create long chains of thoughts before outputting their actual answer to a tricky question. And here's an example of a guy called Kyle, PhD in astrophysics. He was trying the first reasoning model called O1, and he took his the method part of his PhD thesis and asked O1 to build the computer program that he then spent large parts of his thesis developing. And O1 tries and tries and tries and fails and fails and fails, but on the seventh try, O1 does this.
No chance. No chance. No chance. No chance. Come on. There's no way. There's no way. What line are you in? 208. Oh my god, it ran! Oh my god, it ran! That's literally what my code does. It ran.
And then he spends a number of seconds just staring at the wall. This is the feeling you get when you spend 10 months on writing a computer program, and then you can achieve the same thing by spending 1 hour with an AI. This means that AI has been advancing quite rapidly since last time he checked or something like that. Today, we have some, I'm going to list some top achievements that AIs or AI systems have performed. For example, when it comes to medical diagnosis, it is pretty common nowadays that studies show that AI outperforms human doctors in medical diagnosis. But also doctors plus AI. So adding doctors to the human doctors to the equation pretty often now just adds more noise to medical diagnosis when you have good data to build on. In February this year, Google announced something they called Co-Scientist. And at the launch event, they also talked about the research hypothesis that this AI system has built, that they tried to, talk to a group of researchers to evaluate this research hypothesis. And those researchers actually said, are you reading our emails? Because they were going to publish the same research hypothesis, something about cellular biology. It took them 10 years, something like 10 years to reach this research hypothesis. And it took co-scientists 2 days to do the same thing. It was then consuming, of course, massive amounts of research and looking through a lot of things and trying different ideas and then eventually singling out this research hypothesis. In July this year, this summer, LLMs, large language models, for the first time achieved gold medal performance in something called the International Mathematics Olympiad, a pretty far cry from not being able to count to 10. And this fall, we had for the first time a programming competition where AI outperformed all the humans. Previously this summer, AI scored second place. Well, one human still better than AI when it comes to competitive programming. But now AI is the best. This is where AI is today, basically. And AI is improving at more or less an insane pace. It's more or less incomprehensible. When you build, the big AI companies build large language models, they spend compute and they use data to build better and better AI models. And they are, if you measure this in something called effective compute, which means that you also count in that you have better hardware, you have better algorithms, they are becoming 10 times better at creating LLMs for every year. Most of these improvements come from just more data center, more computer chips that they use. But a significant part is also improved algorithms for creating AI. You might think that this Moore's law thing that is saying that computing power on computer chips are improving at a certain rate, that would be important, but that is too slow to have a significant impact here. And just to get a grasp of what this means, GPT-3, the best AI large language model in 2020, took at least a month to train. OpenAI hasn't disclosed how much compute they spent, but analysis show that at least a month to train that. 4 years later, the best data center could do the same thing in 4 to 5 minutes. And that is a factor of around 10,000. All right, so that's the rate of improvement, 10 times better every year. And what does this mean in practice? What can 10 times stronger or 10 times bigger AI models actually do? Well, we don't have any good way of predicting that, but one of the best ways we have is this curve from an organization called Meta. They have collected a large number of tasks. These are software development tasks, so it's just from one particular sector, and then measured how long time it takes for human experts to perform these tasks. And then they benchmark the AI models and see how many of these tasks can they complete. And it turns out that for every 7 months, or for some, depending on how you look at the curve, it could be 4 months, the length of the tasks that these AI models can complete are doubling. So we are now up to, this was the last benchmark model, it can complete half of the tasks that take human software experts between 2 and 2.5 hours. Now we have just seen Claude Sonnet 4.5 released, so it will be interesting to see if it still follows this curve. All right. So, and this means that in 6 months from now, because this graph is 1 month old, we could have something like 4.5, maybe 5 hour long tasks that AIs are able to complete. This is moving fast, and when I say fast, it's kind of important to realize fast compared to what, because this is something relative. I mean, I can do a lot of things in 2 hours or 5 hours, and I can change rapidly as an individual. But when it comes to large organizations, it takes time to change. 5 years is not unusual. And when it comes to, and that could be, for example, a large school, that could take 5 years to change. But when it comes to societal-wide institutions, like educational systems, you have a system of these organizations, or a network of these organizations that should change, and that could require, say, twice the time. And in 5 years, 6 years if you count from now, but you could count from 1 year ago, large language models have gone from barely being able to count to 10 to sometimes performing at researcher level. When reasoning models were released. And that is a rate of change that is difficult for the society to absorb. Speed is the biggest challenge, and it is possible that AI advancements will plateau and stop tomorrow. It's kind of possible, but it's, say, in half a year or something. But it's also irresponsible to assume that it would slow down. And that means we have to assume that AI advancements can continue at high pace, possibly for several more years. And that means that at a strategic level, we have to increase our agility to be able to adapt to changes as they happen, or preferably even before they start to happen. That means we have to look ahead. We have to plan for multiple scenarios. We cannot really know what's going to happen. The developments are too unpredictable for that. And we have to include scenarios that sound incredible today. This exponential change or growth that we're seeing means that we should expect some incredible things. And one of those is that we should not rule out that AI reaches and then surpasses human level intelligence in many areas before the end of the decade. That sounds weird and strange, but that is one of the scenarios that we have to incorporate. Right, so breathing a bit, time for an exercise. I would like you to get a feeling for the rate of change by comparing to how your education or the educational system you're in are changing. And you could either check your curriculum when it was last updated, or look at school books your students are using and see when they were last updated or revised. And then visit a chatbot and ask about the state of large language models in that year. And I have here a suggested prompt that you can use to get something that is pretty readable back. And if so you can see, well, this book was printed in 2022 or 2023 or something. What could LLMs do then? What couldn't they do that LLMs can do now? Things like that. All right. Thanks for watching. I'll see you in another video.